Hey guys, so what we're going to talk about real briefly is period and amplitude, okay? So basically you have a general function, and I should really put an a in front of these real fast. You have a general function, y equals a sine bx or y equals a cosine bx. Now I'm not talking about phase shifts or vertical shifts yet. We're going to talk about that in a couple of days, so we are going to add like a plus or minus h here and a plus or minus k outside the function, and we will talk about that, okay? But for today, we're just focused on period and amplitude, so I'm not really worried about phase shifts or vertical shifts, okay? So, the period is just a simple formula, 2 pi over b, all right? And the amplitude is simply, so I'm going to say capital A to represent amplitude, is simply equal to the absolute value of a, okay? That's the number that's multiplying to the function overall. In Algebra 2, you learned about it as if it was a vertical stretch or vertical shrink. Okay, that's what amplitude basically is. Okay? So let's say we're looking at something like, just something very, very simple. Y equals sine x. Well, what's the amplitude on y equals sine x? Well, what is the number I'm multiplying to sine? Well, it's understood there's a 1 right here, right? So I could say that the amplitude would just be equal to 1. And the period, well, that's just 2 pi over b. b is the number multiplying to x, not to the function, but to x. Okay? So that would be just simply 2 pi over, well, in this case, what is the number multiplying to x? Well, there isn't one, so I can assume it's a 1. So the period would just be 2 pi. Okay? So that means that the understood amplitude for the general sine or cosine function is just 1, and the understood period for just sine or cosine is 2 pi. Alright, so let's practice a few problems here. What is the amplitude on 3 sine 2x? Well, the amplitude is just the absolute value of 3, which is just 3. Well, what is the period? Well, period is equal to 2 pi over b. Okay, what is b for this problem? B is multiplying 2x itself. So that'd be 2 pi over 2. So those cancel, so it'd just be pi. So the period would just be pi. That means my entire sine graph is now completing one full wave and a length of pi. Okay, so every pi units on the x-axis, it has a maximum and minimum, and it returns at the same spot it started, at the same height it started. Okay, what is the amplitude for this second one right here? Where the amplitude is the absolute value of the number multiplying to the sine or cosine function, which is 2. What is the absolute value of 2? It's just 2. So this problem, the period is equal to 2 pi over b. Well, what is b in this case? It's the number multiplying to x, so that'd be 1/4. Okay, now I'm dividing by a fraction, so it's important to remember that if you're dividing by a fraction, it's the same thing as multiplying by the reciprocal. So you can really say 2 pi times 4 over 1, which 4 over 1 is just 4. 2 pi times 4 is just 8 pi. So the period is 8 pi. So in this case, you'll notice that we've stretched it out. Up here, it went faster, right? It went faster. The length of one entire sine wave happened within a shorter time frame, within a shorter x-axis, okay? Whereas on this one, it's going to take much longer to complete one entire wave. All right, so what about this last problem right here? Well, the amplitude is the absolute value of the number multiplying to the sine or cosine function. So that's a -1. What is the absolute value of -1? 1. The period is just 2 pi over b. What is b for this case? Well, it's pi, because that's the number multiplying to x. So the pi's cancel, so you get 2. So once again, this period is smaller than our original period, which was 2 pi. So therefore, it's happening in a much faster time frame. All right, the cosine wave is happening not within a 0 to 2 pi length now. It's happening from a 0 to 2, which is shorter than 0 to 2 pi. It's about a third shorter. I'm sorry, it's about 2/3 shorter. Okay? So, it's just happening. It's starting up at 1, it's going down and going back up much faster than it does when it's at 2 pi. Okay? That's the whole idea here. Okay, so I tried to make this video short and sweet. Some of the hard problems, you do need to know how to manipulate a calculator. But we're going to cover that in class, and I think you guys should already just kind of have a basic idea of that, so I'm not going to cover that in this video. But if you do need help, send me a reminder, send me an email, leave a comment on here, and I'll try to respond to it, okay? Hope you guys have a great day.